Assalamualaikum warahmatullahi wabarakatuh. Hi, we meet again in lab number 2. So the topic for lab number 2 is elements of assembly language. Okay, for your reference, please refer to page 25 on topic 4, elements of assembly language. In this topic, we are going to discuss about the elements of Intel assembly language, and then describe the types and format of statement in the assembly language, and also describe each of the basic elements in an assembly language statement. Okay, now please refer to page 26. Okay, on program 4.2, it is written here, count, and then um, move, move bx, comma 10, and then they have semicolon with bx equal to 10. Okay, so basically this topic, okay, will discuss about this line, okay, this one single line on page 26, program 4.2. Okay, you can see the count. Okay, the arrow there is labeled as label. Okay, what is the use of label? Label or name, okay, we can also call the label as name. Okay, it is used to call the line. Okay, let's say this is line number 1. Okay, count is the label or name for this line. What line? Okay, line move bx, comma 10. Okay, the line number 1 here, the line number 3. Okay, you can see here it is in line number 3. Okay, so this line is labeled as count. Okay, this line is labeled as count. Okay, next is mnemonic. Okay, the mnemonic. Okay, so mnemonic, okay, in the program 4.2, you can see that move or move, the move is labeled as mnemonic. Okay, so mnemonic is the instruction to be given to the CPU. Okay, next is bx and 10. Okay, bx and 10. Okay, in our previous video in lab 1, I have explained to you that bx is a register's name. Okay, bx is a register's name. Okay, so now register's name is known as a operand. Okay, same goes to the value that is to be given to the to bx register. Okay, so this is the value that is going to be given, that is going to be moved into bx. Okay, so the value after the register's name is also known as operands. Okay, so normally, okay, in assembly language instruction, each of the line will have two operands normally, but there are also instruction that only has one operand. Okay, next is command. Okay, command must be written after the semicolon here. Okay, next is command. So command bx equal to 10. The command means as same as command in other languages. Okay, for example, you made a comment after you write C++ instruction. Okay, so comment, okay, let's say the comment is this is for getting the input and so on. Okay, so the command will not be executed by the CPU. Okay, so which one is being executed by CPU? Okay, only the instruction. Okay, so this is the name of the instruction, the name of the line. Okay, This is the instruction and this is the command of the instruction. Okay, can do you get it so far? Okay, hopefully I have described it so that you can understand very well. Okay, next, let's move to table 4.1. Okay, this is table for data allocation directives or data definition directive. Okay, so data definition directive is used to declare a variable. Okay, when we say a variable means we are going to use a memory allocation. Okay, please be reminded that. Okay, BX is a register. Register is located in the CPU. So now, when we use directive in table 4.1 db okay, the direction or the instruction is going to make the memory to give some allocation to the CPU. Okay, memory is outside of the CPU, but as I said in the class, the memory is the best friend of CPU. Only the memory can interact with the CPU. Okay, so now when we use the data allocation directive, it means that we are going to allocate some memory spaces to our calculation. Okay, so what are the allocation direction? Okay, what are the allocations? So we have here db, okay, db, dw, and dd. Okay, so please refer to table 4.1 once again. Okay, db is to allocate and initialize 8 bits of memory. Okay, 8 bits of memory. So when you use db, it means that you are going to allocate 8-bit memory. So all the numbers that you put into the memory, okay, into the db, must be within 8-bit only. DW is used to allocate and initialize words or 2 bytes of memory storage or 16-bit. Meanwhile, DD is used to allocate and initialize 32 bits of memory storage. Okay, let's make an example. Okay, look at the given example. Total DB, okay, sorry, total DB 100. Okay, what does that mean? Total is the memory allocation name that we have created. Okay, we create an allocation of memory storage here, and it is given a name total. DB means the allocation is 8-bit. 100 means, okay, the value that is the initial value of the total variable. Okay, so total is the name of the variable, db is the size of variable that is 8-bit, and 100 is the value of variable that is 100 decimal. Okay, so let's take a look what happened. Okay, what is actually happened to our instruction here. Okay, let's emulate. All right, so when you click emulate, as in the previous video, okay, I have shown you this is the original source window and this is the emulator window. Okay, so in the emulator window we can see how the CPU will assign the values to the registers and the memory and so on. In this simulator, I advise you to uh, run the process in single step mode, not run. Okay, because if you click run, then the instruction will be processed automatically, and you only see the final result. Okay, so let us click on the single step. Okay, when we click the single step, Okay, please look at the bx here. Okay, let's step back once. Okay, so that we can see the changes. Okay, now, okay, the instruction move bx10 will be executed. Okay, bx, look at the bx here. Okay, bx 0000, bh is 00, bl is also 00. Okay, means there is no value added. Okay, so when we hit the single step, okay, please look at the changes happen here. Okay, bx, okay, the instruction given here is move bx10. Move instruction is the instruction that is to give value to the register. All right, so now the register bx has received the value 10 in decimal. So 10 in decimal is equal to a in hexadecimal. Okay, that is why you can see here bx contain a, which means 10 in decimal. Let's see what happened to the line number 2 here. Okay, the total db100 here. What happened to this instruction? Okay, this instruction involve memory or variable. So please go and click on the vars button. Okay, in this button, okay, it will show the defined variable, array and string. So we are not going to discuss array and string. So we use variable now. Okay, let's see. Okay, this is the window for variable. Okay, can you see this? Okay, total. Okay, total is the name of the variable. Okay, and 64 is the value in the variable total. Okay, the size is byte. Okay, the size is byte, mean 8-bit. Okay, you can choose other size here. Okay, so the size is byte, means 1 bit, then it only has one element, and it is shown as hexadecimal. Okay, you can change, okay, the numbers bases here. Okay, when it is in binary, the number is 01100 So if you count it has 8-bit here. Okay, 1 2 3 4 5 6 7 8. Okay, 8-bit. Okay, so this is the value that is allocated for total variable, and the variable is located in the memory, not in the CPU. I think from my explanation just now, okay, we have covered name and mnemonic. Let's move to page 28. Okay, let's discuss about operands. Okay, there are 3 types of operand. Okay, operand type. Okay, first one is immediate operand or immediate data. We call it immediate data. Okay, second, we have register operands. And then lastly, we have memory operands. So what is immediate operand or immediate data? Okay, the data of the source operand is a constant. Okay, when the data of the source is a constant or is a number, so it is called an immediate addressing mode or immediate operand. Okay, for example, this one, move bx10. Okay, the data, the source operand. Okay, this is the source operand. Okay, this is the register operand. Okay, so the source operand is a constant, then we call it as immediate operand. Other example, okay, you can look at program 4.4, move ALX. Okay, X, okay, example, move ALX. X here is a character. Okay, so character is also a constant. And the other example is move AX in bracket 2 plus 4. Okay, let's change the register operand to AH. Okay, let's see what will happen to this three instruction. Okay, that involve the immediate operand. Okay, you emulate. Okay, now we are going to run the move bx10. Okay, we have seen it before. Okay, move bx10, then where the bx will be filled with a. Okay, next we are going to run move alx. Okay, single step. Move al. Okay, you can see here al is 78. Okay, so the 78 is a number that represent character x. Okay, 78 is the number in hexadecimal that represent x. Alright, and then let's do move AH 2 plus 4. Okay, then we do a single step once again. Okay, so 2 plus 4 is the 26 is the representation of 2 plus 4 in hexadecimal. Okay, so these are the examples of immediate operand. Okay, register operand is data of the source operand is in a register, meaning that a data in a register is copied or is moved to another register. Okay, for example, we take bx10 here. Okay, and then we want to move, or we want to copy the value of bx into value of cx. Okay, let's say, okay, move cx bx. Okay, let's emulate. Okay, now we do the move bx10. Okay, so a is inserted into bx, and then we do move cx bx, means we want to copy the content of bx into cx. Okay, so click single step. Okay, you can see that cx also contain a. Okay, 0 0 0 a. Okay, it's mean that this is the process of copying the value in bx into cx, and at the same time the value in bx is not vanished. Okay, because um, there is no instruction to vanish or to remove the value in bx. Okay, please remember, computer works on instruction. Okay, if there is no instruction of remove, then the value will not be removed. Right. Next is the last operand is memory operand. Okay, where the data of the source operand is in the memory. Okay, now we have the memory here. Okay, so let's do the source operand. Okay, let's take a memory as a source operand. Okay, memory operand is the data of the source operand is in the memory. Okay, let's do one example. Okay, let's move this 100 decimal value in the total variable into a register. Okay, let's do move dl1 total. Okay, why I use dl instead of dx? Okay, the operands, these two operands, okay, the register operand and the source operand must be same in size. Okay, total, we declare total as db, which is 8 bit. Okay, 8-bit. So the register D also must be the same size, which is 8-bit. Alright. Okay, so we cannot use dx. Okay, what happened when we use dx? Okay, let's try. Okay, move dx total. Okay, and then we emulate. Okay, what it is said here? Wrong parameter, move dx total. Operand do not match. 16-bit register and 8-bit address. Okay, so the operand size is not matched. Okay, so that's why we have to use only 8-bit register, which is DL or DH, either one lah. Okay, okay, single step. Okay, we can see that move BX 10 here, and then total. Okay, we can see it total 100 here. And then single step, move DL total. Okay, in hexadecimal, okay, 100 is 64. Okay, let's see whether the 64 hexadecimal is inserted into DL or not. Okay, then run the single step. Alright, so we can see here DL has received the number of 64 or the value of 64 hexadecimal from total. Okay, so DL here, you can see it contains 64. Alright, so the last part in this lab is command. Okay, I have explained to you about the command here. Okay, the command will not be executed by the emulator or the CPU. Alright, so I think that's all for lab session number 2. I'll meet you again in the next video. Until then, happy virtual learning and bye-bye.